Fatigue test. So this is some of the glass that we use in our products. I'm showing how robust this is. This actually has been running, I think now since 12 o'clock. I set this up really early. And it's just been fatigue cycling away. So this glass is really tough and really durable. And we have a few tests that we use to ensure that there's no failures or problems with this glass. Water and soap mix. So we use these particles. These particles are actually sharp particles that produce wear on all the paints, and we can modify our paints and anything like that. So we use this to ensure that the foam looks good over the life of the phone. For a manner of different tests, or a multitude of different tests, I guess I would say. So here we have a battery cycle test. This will ensure the contacts stay good over the life of the phone. Here we have a USB cycle test, so inserting and removing the USB over and over. We do load measurements, pre and post testing to ensure the quality of the connectors. Same with over here is a fatigue test. So this is looking for, make sure that the USB can take repetitive loading over the life cycle of the phone. And same here is this is for the main key cycle. So buttons get pressed over and over, and these are actually mechanical switches, so they need to be tested for robustness. Back behind you, you can see that there's actually some component. We do component testing here as well. So there's some, those are actually camera switches. So we do tactility and durability on those. So those, and for all the switches actually, not just the camera, but that one specifically is a camera switch. Next to it's some of the push-out. We do all the adhesive testings. A lot of times the windows are held together with an adhesive, the camera windows, anything in there. So we measure the forces and the loads that are associated with putting those together. So that just ensures that, once again, it stays, the phone is reliable over the entire life of the phone.
What about temperature and humidity testing?
Yeah, you'll see more of that, but we do have that. So post these tests, once it goes through these, we do testing here as well, and it goes through a damp heat profile and cycling as well. But you'll see a bigger version of that. So we mainly do it after the mechanical test, and then there's the next lab. A wear tester. So this simulates, being in your jeans pockets. We will have the phones in here sliding back and forth, as well as it's got the same kind of cones that are placed in with the phone. So we can see the kind of wear that will happen, in a purse. We can put keys in it, we can put coins in it. And we use that to feed back to the design engineers and the paint specialists on how well one of our coatings is doing, or if we want to put a hard coat on or do any modifications to make it a little tougher. This is just our chemicals, like a lot of the chemicals. You wouldn't think maybe it would be a problem, but some of these normal household chemicals actually cause some fits to the phones, to plastics, let's say, to different materials. And so this is just a wide variety. And if you think about it, like the phone gets subjected to all these different things. If you eat your French fries, this actually does cause quite a bit of problems to different kinds of plastics. It's crystal oil. So like French fry grease you'll have on your hands. You go to the beach, you get copper tone on your hands. It does tend to cause problems. So we address that through applying the chemicals onto the phones, and then typically we actually will move on to a mechanical test and check the reliability post chemical application. We also check staining. So makeups, lipsticks, those types of things can cause staining depending on what materials we use too. So we do that as well. So depending on what kind of form factor you have, obviously we have some flip cycles going, we have some slide cycles going. So it's repetitive testing to ensure the mechanics going. There's usually a flex that's run through there, so we have to make sure that there's no fatigue in the flex. Because if we introduce connection between the upper and lower boards, then obviously you're going to have some issues. And as you can see on the screen, we also work with a finite element analysis. There's a guy upstairs who actually has the models of the phone, and so you can run these, and it shows like the deflections and stresses internally that occur when the phone's dropped. So after this, I'll show you our one little drop tester that we have up here. But this is kind of, you can take a look and you can see all the internal mechanics flexing and all the things that the mechanical engineers really have to deal with. during an impact.
Is that live or is that just a...
This is a model.
Okay.
This is an actual model of the design part that's put in. But we do have, you'll see in the next lab, you'll see a high-speed video that actually catches that as well. So that's what we usually do. We'll take a high-speed video and correlate it with this model that the FEA guy puts together. And then I also sometimes will apply a data acquisition system where I can actually measure stresses and strains on each one of those locations. This is also kind of a carrier spec. This is actually my phone, so we'll see if it breaks. I'm just going to go from, like, this is actually going to be way out of the spec. But I'll go shoot for the top, so we'll see what happens, and hopefully it's good. So we usually do this multiple times, multiple locations, and you know, depending on the construction of the phone, there's multiple layers of glass sometimes for the touch panels. So there's the upper glass panel, then there might be a touch panel that's actually made out of glass, then you have the LCD, which actually has 2 panes of glass. So there's a lot of glass in there to break. So this is kind of, you know, simulating hitting an irregular surface. And we do it more than in the middle. Actually, there's nine locations plus around the driver that gets done as well. So that's one of another main test. A fun impact test. We worked with the students over at UCSD to develop this. You'll see, no problem. You'll see a drop test down there. This is actually what we do to research stuff. You'll see the drop and tumble testers downstairs. If we do have a problem that's like kind of an isolated problem, maybe a specific corner is giving us trouble, this is the machine we use to really analyze it, because I can do repetitive hits exactly in one location. So I can show you this. This is going a little higher. This is going 2 meter hit.
Watch out there. I might get scared.
It's a little bit this way. So it's 2 meter hit. This is a little higher than what we typically test to. But it comes down and gives this thing a good chucks in. Yeah, go. Exactly. And you know, like, sometimes they do come apart, but we're not overly worried about that because, you know, people can put their phones back together, and then we'll see what happens. So she still fires up, except, so there you go, still good. So that happens multiple times as well, so over and over, and before these products are released. And I think that's basically it for me, unless you guys have more.
Hi everyone, welcome to our lab. My name is Miley Reyes and I'm one of the test engineers here at our lab. So I'll be doing a quick tour or to give you a glimpse of what we do around here. So just a brief introduction. We do a lot of environmental and mechanical tests here. We test to fulfill industry requirements and of course our own Nokia requirements. Of course, we strive to exceed these requirements too. We recreate conditions that a phone might possibly go through in real life. So we bring phones here as our job, and we analyze them. So it's always fun. It's never a dull moment around here. So we only have a short time to show you what we have. So let's start. So we'll start with the lab. We'll end the chambers here. With these chambers, we create test profiles that simulate conditions or simulate extreme weather conditions. Low temperatures, high temperatures, humidity, quick changes in temperature, slow changes in temperature. So think of situations such as, let's see, maybe you have phone in your car in Arizona in the summer, that's pretty fun. Or rainforests of South America, high humidity areas, and or snowboarding in Whistler, Lake Tahoe. So right now I have this one here running 65 degrees C, 93% humidity, so that's pretty hot, 65 degrees Fahrenheit. 150 So we want to see how the survive. So over here, so observe or we try to see what the survivability is of a phone in environments such as coastal areas, such as like the beaches. And over here,
Wait, let me get out of your way.
we have
You're taking
dripping water, our most expensive equipment, dripping water tester. So we put the phones through this test and we observe what happens to the phone. And one of the things that we do here is we use a water-sensitive spray, such as this. And we put the spray on certain parts of the phone, like the internals of the phone, and we put it through this dripping water test. And then with that, we can find out where the liquid, where the water gets in. So I can show you, like for this one, we've already put some spray on it. So, because this changes color pretty well. I put my phone in my pocket all the time. I sit on it, I put a lot of pressure on all different kinds of pressure on it. So these machines simulate conditions like that. So this is the bending machine. You can see the displacement this force causes on the phone. And then on the other side is our twist. We have a few solar radiation chambers. Solar radiation can have some damaging effects on the materials, such as plastic. And one obvious effect is the discoloration or fading of materials. So we look for things like that with this test. And then over here, I have it set up. I'll start the dust test pretty soon. So I put my phone in my pocket all the time. You know, there's lint in there, and then you go to the beach, there's sand. So foreign particles can get in the phone, or we want to see what happens to the phone if foreign particles do get inside the phones. So let me show you. People get a little loud in here, so just letting you know. Just put the phone in here. I have one already inside. Control the speed of the tumbler. I set it tumble a few times. And check the phone after. So with this, the phone hits the floor in random positions. Just run on that. There's two logos. How that is. And over on this side is another set of drop machines. This has a more control of the drop. Here we can control the height of the drop and the position of the drop. And, I can show you. So this one I set it up for 1.5 hours.
What did you say? 1.5?
Neither.
Drops onto a concrete surface.
Give you a That's what we do here. We actually have high-speed cameras that record the drops. And I have one set up over here. I don't have time to show you how it works, but I have one on that's been done. So they're fitting on that.
So using how much of things.
Yeah.
Yeah.
So after all our phones go through all these tests, we inspect, we do a thorough inspection of the phones. We look for obvious and not so obvious effects on the phone. And for the not so obvious effects, we have another lab that analyzes the phone on a microscopic level. I guess that's the next lab you're going to check out, the failure analysis lab. Hello.
Hello everyone, welcome. So, as Jean was saying, this is Nokia's Physical Failure Analysis Lab. My name is Mike Wellborn. I've worked for Nokia about 11 years, and I've worked in the industry for 25. So, what I'd like to do is tell you a little bit about what we do in this lab. This lab is part of a global group of labs within Nokia. So, each R&D site in Nokia has a lab similar to this one. And what we do is we analyze phones and we collaborate and share our findings with the other labs to ultimately improve the quality of Nokia phones. So I'm sure a lot of you are familiar with the show CSI. Well, this lab is kind of like that. It's kind of CSI of Nokia. So, but CSI, what they're looking for is to try to solve criminal cases, but we're trying to solve phone failures. So not every failure within Nokia requires this level of analysis. For example, let's say you just saw the drop testing, right? Let's say you're doing drop testing, you drop the phone and the display stops working afterwards. But there's a big crack in the display. That's a pretty obvious failure mode. The display breaks because it's cracked. It doesn't require this level of analysis. But let's use that same example where you take and you drop the phone, display doesn't work, but there's no physical damage to the phone. There's no cracks, dents, breaks, anything at all. So that's where this equipment comes in, because this equipment allows us to see things that you can't see with the naked eye. So just as an example, I'd like to kind of demonstrate how we use the equipment by going through one of the failure analysis that we've done in the past. So let's use that same example where you drop the phone, the display stops working, but there's no physical damage to the phone. So we'll get the phone, we'll do some electrical probing, and let's say that we determine that it's a component that's soldered to the circuit board of the phone. So over here, I just want to show you. So what we'll do is we'll take the circuit board, we will cut out that component, and then we will encapsulate it in epoxy. And then using the equipment behind you, we we will take and polish and grind to the precise location that we think the failure is occurring. And then once we do that, I'd like to show you over on the microscopes what we actually found during this analysis. So